Hello and welcome. In this video, we're going to talk about the second fundamental theorem of calculus and how to use integrals to find the average value of a function over a given interval. So let's go ahead and jump right into the second fundamental theorem of calculus. The second fundamental theorem of calculus really ties together the idea of inverse functions. So an integral is the inverse operation of a derivative. So if we took the derivative of the integral, really we're undoing those two operations. So think about this as inverse operations. The key difference, though, is if we are looking at bounds on our integral that have variables, we need to keep in mind what's happening, sort of like a chain rule potential for what's going on in that particular circumstance. So what we're going to be doing for most of these problems is we're going to be considering plugging in the top bound of your integral into the integrand, the inside part of your integral, and multiplying that piece by the derivative of the thing that you're plugging in. So we are first going to plug in top bound, and not into the antiderivative, plug it into the integrand, into the piece that's already written inside, because we're taking the derivative of the integral, which means we're not actually interested in finding the antiderivative, we're interested in evaluating the derivative of the antiderivative. So you're going to plug in the top bound into the integrand, then you're going to multiply that by the derivative of what you plugged in. So let's look at some examples here. Notice the directions are what tell us that we're actually taking the derivative. It says practice the second fundamental theorem of calculus to find the derivative of the following integrals. So we are being told the very first thing we need to consider is that we're taking the derivative of each of these integrals that are written here below. So step one, look at your upper bound. Plug that in anywhere that there's a variable into your integrand. This piece right here is my integrand, so I'm going to replace t with x. So this is going to become 3x squared minus 5. Then I'm going to multiply that by the derivative of x. Well, the derivative of x is just 1. Now I've dealt with the upper bound, I'm going to deal with the lower bound. I'm going to plug in the lower bound, which is 0. So this is going to become 3 times 0 squared minus 5. That's just going to be negative 5. And then I'm going to multiply that by the derivative of 0. Well, the derivative of 0 is just 0. And then we're going to simplify what's left. This is just 3x squared minus 5, even if I multiply by 1, minus 0 times 5 is still 0. So this is going to be our final simplified answer. So the second fundamental theorem of calculus, if we're taking the derivative of the integral, we're looking at the integrand, the inside part, the part in between the integral symbol and your dx or dt. We're evaluating that at the upper and lower bounds and multiplying each of those evaluation steps by the derivative of that particular bound. So let's look at number 2. The very first thing I'm going to do is plug in the upper bound. So instead of 3t, I'm going to have 3x squared. Then I'm going to multiply that by the derivative of x squared, which is 2x. Then I'm going to subtract. I'm going to plug in the lower bound. So 3 times t is going to become 3 times x. And I'm going to multiply by the derivative of that lower bound, which is 1. Then I'm going to simplify. 3 times 2 is 6x to the third power minus 3x. That's going to be my final answer here. For number 3, if you're feeling up to it, go ahead and pause the video and see if you can work through it on your own. Otherwise, we're going to jump in together. So hopefully you had time to pause the video if that's what you wanted to try. If I plug g of x in here, that's just going to become g of x plus 1. I'm just plugging g of x in for t. And what's the derivative of g of x? Well, it's just g prime of x. It's not a value that we know, but we know that it's g prime of x. Minus, if we plug the lower bound in for t, we're going to get f of x plus 1. And we're going to multiply that by the derivative of f of x, which is f prime of x. So I'm going to rewrite this just because it got a little cut off there. G of x plus 1, this is getting multiplied by g prime of x, minus f of x plus 1, and that's getting multiplied by f prime of x. So our final answer, that's as simplified as we could possibly get for these functions. So unless you're being told to use the second fundamental theorem of calculus, this isn't something that you're just necessarily looking at on your own. The directions need to indicate either that you're finding the derivative of the integral or that you're being asked to use the second fundamental theorem of calculus. Let's go ahead now and look at the average value of a function and the mean value theorem for integrals. All right, the average value of a function is equal to the average y value over a particular interval. The average y value, f attains over a closed interval. The key thing here is that we have to be talking about a continuous function. To find the average value, really what you're doing is you're multiplying. If you think about average as the mean back in lower level math classes, you're going to multiply the length of the 1 over the length of the integral, so 1 over b minus a, by the area under the curve, right? The integral from a to b of f of x dx. So you're finding the whole area and you're multiplying it by 1 over the top bound minus the bottom bound. So this is the formula that you're going to use to find the average value of a function. So let's jump in and work through this. Given that f of x is equal to 3x squared minus 2x on 1 to 4, find the average value. So first of all, I want to just point out that f is continuous, so we're allowed to talk about the average value. If it wasn't continuous, it would be harder to work through this and justify it to ourselves. So f average is going to equal 1 over, in this case, b is 4 and a is 3. So 1 over 4 minus 1 times the integral from 1 to 4 of the function 3x squared minus 2x dx. I encourage you to pause the video and try and work through this antiderivative on your own and then unpause the video and see how you did. So this is going to become 1/3 times, if I find the antiderivative here, that's going to be x to the third minus x squared, and I'm evaluating that from 1 to 4. That's going to be 1/3 times 4 to the third minus 4 squared minus 1 cubed minus 1 squared. This is going to be 0. So this is going to be 1/3 times 64 minus 16, or 1/3 of 48, which is 16. So the average value of the function 3x squared minus 2x from 1 to 4 is 16. If I considered all of the values that it obtained from 1 to 4, the average of all of those values is 16. Now we're going to extend this idea a little bit to talk about the mean value theorem for integrals. So if you remember back to an earlier chapter, we talked about the mean value theorem for derivatives, and that theorem said that if we have a continuous and differentiable function, then at some point the average rate of change, or the slope between 2 points, would be equal to the instantaneous rate of change, or the derivative. The mean value theorem for integrals is really talking about the same idea. If we have a continuous function, and here's the average value formula again. If we have a continuous function, which would mean this would be our average value, then there must be some value, c, such that f of c is equal to f average. Meaning, at some point, if we're talking about a continuous function, the average value has to be equal to the area under the curve. So let's look back at the example that we just looked at. The example we just looked at, and I'm going to just rewrite it here, was 1/3 times the integral from 1 to 4 of 3x squared minus 2x dx, and we found that to be 16 just before we did this in the video. The mean value theorem says for integrals, at some point this function must actually be equal to 16 in order for that to be true. So we can say that at some point 16 needs to equal 3x squared minus 2x, and we can move 16 to the other side. 3x squared minus 2x minus 16. This looks like it's going to factor. 3x squared is 3x times x. 16 is 2 and 8. That's -8, +6. That works out. So this gives me two x values that would make this true, 8 over 3 and -2. Now we only care about the interval from 1 to 4, since that's what we were considering before, which means this answer doesn't make any sense in context to this problem. So C equals 8/3 is going to be the value within the interval that verifies that the mean value theorem is true. So let's look at 2 last examples and then we'll go ahead and wrap up this video. So we are going to find the average value of the function, the absolute value of x minus 2, on the interval from 0 to 4, and then we're going to apply the mean value theorem, or determine if the mean value theorem applies, to figure out what particular C value would work in this case. So I encourage you, if you're feeling pretty confident, to go ahead and pause the video and work through this on your own. Otherwise, follow along with us. Okay, so I'm going to do all the work under number 5, even if I'm doing part of it for number 4. There's just more space down here. One thing I want to remind you, as we talked about in previous videos, is that the absolute value of x minus 2 is equal to the opposite of what we see if x is less than or equal to whatever makes the inside 0, and the inside would be 0 if x was 2. And it's exactly what we see as long as x is greater than that value. We are looking on the interval from 0 to 4. So if we're looking from 0 to 4, we need to consider both pieces and split our integral into 2 integrals. So this is tying back something that we covered in 4.4, part 1, the idea of splitting an integral for absolute value. So I'm going to rewrite this integral as 2 integrals. So instead of just saying, so we're really thinking about the integral from 0 to 4 of the absolute value of x minus 2 dx. But if I'm going to rewrite this, this is going to be, and I should have 1 over 4 minus 0 here. This is going to be 1/4 times the integral from 0 to 4 of this piece of the function. Oops, not from 0 to 4, but from 0 to 2 of this piece, negative x plus 2 dx, plus the integral from 2 to 4 of this piece, x minus 2. So we're just adding on a little bit of a challenge with the fact that it is an absolute value, which means we have to split it into 2 separate integrals. So this is going to be 1/4 times, if I integrate negative x plus 2, I get negative x squared over 2 plus 2x. This is going to be evaluated from 0 to 2, plus x squared over 2 minus 2x, and this is going to be evaluated from 2 to 4. So I'm going to keep my 1/4 in front. If I plug in 2, I'm going to have the opposite of 2 squared. So negative 4 divided by 2 is negative 2, plus 2 times 2 is 4, minus 0. And if I evaluate the blue over here, if I plug in 4, 4 squared is 16 divided by 2 is 8, minus 2 times 4 is 8. So that's going to just end up being 0. Minus, if I plug in the bottom, 2 squared is 4, divided by 2 is 2, minus 2 times 2 is 4. So if I'm going fast, pause the video, give yourself time to work through that basic calculus simplification here. This whole thing is going to simplify to be 2. This whole thing is going to simplify to be the opposite of negative 2, so also 2. And if I multiply a 1/4 by 4, I'm going to end up with 1. So the answer to number 1 is that the average value of the curve, absolute value of x minus 2 on the interval from 0 to 4, the average value is 1. Now for number 5, we need to determine if the mean value theorem applies, which it does. So for number 5, the very first thing I'm going to say is f is continuous on the interval from 0 to 4. Therefore, MVT applies. And what MVT says is that what we just found at some point must be equal to the original function. So 1 is going to be equal to the absolute value of x minus 2. Well, what number between 0 and 4 would make this inequality true? If I need x minus 2 to be equal to 1, then x is going to need to be 3. So the C value that would make this true would be 3. Now, if I plugged in 1, I would have 1 minus 2 That would also work, wouldn't it? If I had 1 minus 2, I'd get negative 1. The absolute value of that would be positive 1. So we actually have two C values that confirm that this does, in fact, work. So let's recap what we covered in this video. We started by talking about the second fundamental theorem of calculus, which says that the derivative of the integral is the same thing as just plugging in the bounds into the integrand and multiplying each particular bound by the derivative of that bound. We then talked about the average value and how we could calculate the average value of a function over a given interval by looking at 1 over b minus a times the integral from a to b of f of x dx. And then we wrapped up by saying that the mean value theorem for integrals guarantees that there is some c value in the function f that verifies or guarantees that we actually reach that average value at some point in time. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.